Let's solve this problem together. If 5.17 grams of an unknown substance X that is a non-electrolyte lower the freezing point of 200 grams of benzene by 0.84 Kelvin, what is the molecular weight in grams per mole of X? First, let's go over the concept of freezing point depression. Freezing point depression is this phenomenon when you dissolved a solute in a solvent to create a solution, then the freezing point of the solution is always lower than the freezing point of the pure solvent. So if you have TF solvent as the freezing point of solvent and TF solution as the freezing point of solution, then you'll always have TF solution smaller than TF solvent. And there's also something called delta TF, or freezing point depression. That is just simply the difference between the freezing point of the solvent and the freezing point of the solution. And there's a formula to calculate delta TF. You're just going to take KF times molality of the solution. Here, KF is the molal freezing point depression constant, and that is specific to different solvent. And you also have the small m right here is molality, or moles of solute per kilograms of solvent. So we'll keep that in mind right here and move on to solving this problem. So we notice that in this problem, the solution consists of 5.17 grams of X dissolved in 200 grams of benzene, and we are provided that the KF value for benzene is 4.90. We're also provided that the delta TF is 0.84 Kelvin, and we need to find the molecular weight of X. So let's think about how to solve for molecular weight. You'll need to take the mass of X divided by the mole of X. For mass of X, we already know from the prompt that there is 5.17 grams of X, so really all we need to find is the mole of X. So where can we find the mole of X? Well, we can find the mole of X by looking at the formula on how to calculate delta TF, right? So earlier we talked about delta TF equals KF times molality, and if you expand on that, you'll have KF times mole of X divided by kilograms of benzene. Here we can see that we can solve for mole of X from this formula of calculating delta TF, and from there you can plug it back into the formula to calculate molecular weight of X. So we'll go ahead and calculate mole of X by first deriving the formula for mole of X, and that's going to be delta TF times kilograms of benzene divided by KF. Once we got the formula, let's plug in numbers in. That's going to be 0.84 times 0.2 divided by 4.90. And that's going to give us 0.044 moles of X. Once we found the mole of X, we just simply substitute it in to find molecular weight of X. That's going to be 5.17 grams divided by 0.044 moles of X, and that's going to give us 152 grams per mole. That is the answer to this question. If you're interested in more practice problems on this topic, please consider purchasing Easy Chemistry worksheet on colligative properties of solution. You can also get the worksheet for free by subscribing to Easy Chemistry YouTube channel. Details is in the description. Check it out. Thank you for watching.